2026 United Nations Climate Change Conference, President Society of Renewable Energy ITK, Head of Mechanical Robotic ITK, Electrical Division Enggang Electrical Vehicle Team,
So please welcome our moderator to Muhammad Iqbal Sugiarto. The time is yours.
Okay, thank you, Abdul and Lia, for the humble introduction for me. Good morning, ladies and gentlemen. Honorable Mr. Himawan Wijaksono, SST MT, as the head of Industrial Technology and Process Department at Kalimantan Institute of Technology. Honorable Ms. Barkatun Hasana, STMT, as the head of Electrical Engineering Department at Kalimantan Institute of Technology. Honorable Ms. Amalia Rizky Utami, STMT, and Ms. Kristi Jayanti Yuniag, STMT, as chair of this committee, Pejuang Inovasi Nasional. Honorable Dr. Hawang, as the first presenter on this international webinar from Monash University, Australia. Honorable Mr. Eduardos Jonathan Sutanto, as the second presenter on this international webinar from PT Surya Utama Nuansa, or Star Capital. First of all, let us thank you to Almighty Allah Subhanahu wa Ta'ala. Because of His blessing, we are able to come here to join in this international webinar. Ladies and gentlemen, the presentation today is about artificial intelligence to build the nation's capital city with renewable energy. Now, I will read one by one the agenda today. The first section is opening. The second section is introductions. The third section is presentation time. The fourth section is opinion, question, and answer. And the last section is closing. Well, ladies and gentlemen, the modern energy sector is getting more connected with digital technology that facilitate and accelerate the energy transition. The energy transition currently underway is causing the breakdown of barriers, bringing about the market changes and the emergence of new players. One application of the energy sector that is quite prominently is the technology smart grid. Smart grid cover modern information and communication technology that will improve the quality of smart grid development network, similar to development of Industrial Revolution 4.0, where the artificial intelligence, automation, and the internet are changing conventional industrial practices. Smart grid cover modern information and communication technology that will improve the quality of our electricity grid to be more efficient, more reliable, as well as increase consumer participation. The renewable energy in the electrical system, that complexity of electrical power system leads to need for building monitoring system and trigger our great need for energy digitalization. To overcome the problem is necessary to hold this webinar, Artificial Intelligence to Build the Nation Capital City with Renewable Energy. The webinar itself a forum of society to motivate and increase the knowledge about the world of artificial intelligence and renewable energy sector. Let's move on the next agenda. The next agenda is the presentation section. The question will be merged into one time after two presenters done about his presentation. For the presentation and participate, you can ask the question with the future raise hand on Zoom meeting or ask the question on chat box. You can ask the question with two languages, English or Bahasa Indonesia. For the first turn, will be given by the first presenter is Dr. Hawang. On professional summary, Dr. Hawang primary research interests in optimization, data analytics, and machine learning for smart power and energy system, with a recent focus on the integration of distributed energy research like renewable energy, energy storage, and demand response. Interdisciplinary background in power, economic, and machine learning. Now, Dr. Hawang is lecturer on deputy lead of IT Sustainable Energy at the Department of Data Science and AI, FIT Monash University, Australia. Dr. Hawang had 5 selected publications on AI and machine learning for energy, 5 publications on data analytics of energy, 5 publications on blockchain for energy, 5 publications on optimization for energy, 10 publications on incentive of economic for energy, and 5 publications on emerging ICT. Wow, so amazing. Many much publication for our presentation in this international webinar today. Okay, Dr. Hawang, ladies and gentlemen, this is first presentation with AI-enabled smart consumer and smart electricity. Please welcome, this is Dr. Hawang. Time is yours.
Thank you so much for the introduction. Now I'm going to share my screen and let's see whether you can see it. Okay, can you see my screen now?
Yes, can you see Mr. Dr. Hawang?
Okay, good. Yeah, so I think I'm gonna probably keep, I think I see the schedule. I'm gonna make the whole presentation like within, I think 50 minutes, but probably, well, hopefully not running out of time. And then I think later on, after that, probably an hour later, we have a Q&A, okay? So first, it's kind of a great honor to be here to present some of my research and also the research activities in the area of AI for energy, for smart consumers, for smart energy cities in this great event. So I think I've been here last year and it was it's a lot of fun, a lot of great question feedback. So it's great to be here again to talk about another different kind of topic, more focused on AI technology and how that we can use for like enabling smart energy city, smart consumer, smart grid, right? Everything for us to how to use energy and how to generate energy or in a smart way and how to manage that. Okay, so yeah, so I'm Hao Wang from Monash University, Department of Data Science. I'm affiliated with this department and also Monash Institute, Monash Data Futures Institute. So all these 3 different organizations, basically my research is in the area of IT-related technology, including AI, other like optimization, data analytics, or in the area of energy and smart, and also transport. So let me just go straight to the outline of today's talk. So I'm going to talk about first very briefly on like who we are, Monash University, and also 3 different parts: the climate change challenge, right, that we have, and the net zero roadmap. A lot of countries have really developed some kind of roadmap or plan for the country to towards net zero. Mostly in 2050 or sometimes in 2060 or 70, but there's a very clear like roadmap to achieve that, and certainly AI plays a big role here for us to like really enable and facilitate, right, the future energy system, right? So I'm going to talk about that. What's the new kind of characteristics, features, right, of the future energy system, and also I give like 2 parts of kind of applications, right? So AI for consumers and also AI for smart energy cities. I think that kind of fit into the scope of today's event. Okay, so yeah, very briefly on Monash University, we are in the group of 8 research universities in Australia. I think just a couple of days ago that US News released their 2022 best global university rankings. Then we are in 40 globally. And also in the QS ranking, we are also among like a 55 last year, this year. And also we are kind of climbing up. And each year we do see that our ranking goes better, but certainly ranking is not everything. we do good research, we deliver good education programs, and we try to contribute right to the society in Australia and also in the Southeast Asia and also the globe. And also, I think there's a strong tie or increasing tie or connection between Monash University and Indonesia, that we probably are the first foreign university gonna have a campus in Indonesia, and already started, I think, this year with few students probably, and also there's a huge opportunity there for your career as well, I guess, and certainly will be more strongly kind of connected between us for to work together in the future. And our faculty is faculty of IT, so we have different departments. So I'm in the data science and AI. The other departments include like a human-centered computing. Basically, it's about human machine interaction, and also the other department about software engineering, cybersecurity, networking. And also we have a very kind of what the university and our faculty has a very strong view on kind of some strategic research areas, and that are going to make a huge impact. So one is digital health, and the other is IT for sustainability, and sustainable energy is part of this. And I'm the deputy lead of this research thing, and well, particularly in the area of energy. So in our faculty, that we actually build a strong and kind of group in around energy research, especially from the data science and AI perspective. For example, we have for research areas include like smart energy system optimization. We have world known expertise in the area, III fellow and other professors in the area doing optimization. And we also have a lot of research activity, quite active on AI for smart decision making for energy. They use a lot of different tools in this area. And we do a lot of also data analysis for energy, including like forecast, including segmentation, clustering, a lot of different tools being used for energy system analytics. And we also work on energy market and economics. And actually, our Institute of Monash Energy Institute director has some collaborations with Indonesian power operator to like design the energy market in Indonesia. So we do have a lot of kind of working relationships between the colleagues right in Indonesia and us at Monash. We also try to build a kind of smart energy city here on campus for the university, which is also one of the very earliest one in Australia and probably also in the world, that will try to have a microgrid for the campus. And we have solar energy, battery, EV charger. We have control room for that. We have a lot of communications running on it. We have smart buildings, smart probably like student dormitories. So a lot of like research activities here, and we have like a real world we can see kind of this Monash smart energy smart energy city here. Okay, so first let me go to the first part for today's talk about the kind of climate change issues and net zero roadmap and how AI could play a role here. So, well, certainly, I think climate change is not like I think we all know it, and there might be some arguments around whether there is climate change, especially in in the past 4 years when in the U.S. The Trump administration basically denied that there's climate change, right? But I think the majority, especially among the scientific community, that we do believe that the climate change is happening. And that causes a lot of different like natural disasters, right? You can see here some of the kind of unusual like weather, and also like wildfires, right? And also that can actually kind of harm actually the well-being of people, right, and their lives, and also like affect like the agriculture and sectors, right, energy sectors as well, transport, basically kind of a daily life for people, right? So that's the reason, right? There's a strong, actually, kind of effort that we put into globally to pursue this concept, so-called net zero, right? So we try to reduce the carbon dioxide emissions, right, and try to basically achieve net zero. Basically, we don't want to have any carbon dioxide emission. And you can see here, a lot of countries, right, already set. I think this is a figure probably from last year or something. Indonesia is not among here, but I have another slides for some recent news of Indonesians' view on the net zero. So you can see a lot of countries kind of flags here showing that their commitment, right, to deliver this kind of net zero, right? So in different years, for example, and some are kind of pretty ahead. For example, we can see here European Union, they're gonna achieve the target a little bit earlier, and a lot of countries like Sweden would achieve net zero a little bit earlier than other countries, right? And the US also committed to that, but we haven't seen like a really concrete plan for it. And also a lot of other countries, like in Asia, including Japan, gonna do that for sure, and other South. Well, here I think the statistic that doesn't include a lot of, say, Asian countries. In Asia, that China also has the most kind of impactful, like climate kind of impact in terms of that, and also there's also like a commitment, right, to deliver net zero by 2060 and try to achieve the peak of emission by 2030, right? It's just it's 2030 or something. Don't remember exactly. Yeah, so a lot of countries do have that. So how to achieve that, right? So in general, so this is kind of a general roadmap for net zero, but different countries certainly have different views and different like measurements, right? And also different like tools to achieve net zero, so for sure. But as you can see, definitely that, so the effort actually already started, right? So the emergence of some of the efforts, for example, like to reduce waste, right, and to kind of improve energy efficiencies for buildings, and certainly that's gonna play a huge role. And also, there are like some other efforts right now. You see a lot of electric vehicles, right, and the installation, a lot of solar panels, large wind farms, even large battery systems, right, and smart home concept, smart buildings, right. So all this actually would be part of this net zero, say, kind of roadmap, right? So certainly to achieve a full decarbonization, right, in the future. And also that kind of affect a lot of different sectors. Certainly the energy sector, or so-called the power and energy sector, are gonna be to install a lot of renewable generations, right, to make the consumer smarter, to be part of their operation, and to run the system, the energy grid, right, in a smart way, and to kind of accommodate, right, very high uptake of like distributed energy resources, sustainable, low carbon energy resources, right? And in addition to energy sector, actually, there are like efforts also in like the agriculture industry, right, to have like reduce their carbon emission, and also in the transport sector, basically that kind of another big part of the carbon emission. So like transport, including like trains, right, like cars, right. So we're gonna have all so-called like a transport electrification, right, to reduce their reliable kind of dependence on the fossil fuel. And also great efforts spent in the construction sector, basically to improve energy efficiency. And also there are from also strong commitment from the governments. For example, in California state government mandates all the newly built house across whole California state from January the 1st, 2021, already this year started. So if you want to build a new house, you have to install PV generation. Otherwise, you will not get approved. So that's also the regulatory part, right? That affect people's life, but towards this kind of net zero, try to have a greater or like a high uptake of distributed, sustainable, low carbon energy resources. Okay, so this is kind of something general, and this is the roadmap specifically in the US that they try to increase, try to achieve net zero carbon emissions by 2050. But certainly, a lot of things to do for them. So they want to do, for example, here the 8 actions, right, in about 10 years' time. Mostly in the part to eliminate energy generation from coal. And the gas is a different story. Gas has slightly, well, actually more or less carbon emissions. And in terms of the generation of gas, it's it's better in terms of the kind of carbon emission, and also can respond fast to provide services to generate better than coal. So coal gonna be eliminated, and also in China that stopped outsource, right, different like coal-powered power plants overseas. That's also great news. And also try to like increase the vehicle EV electric vehicles sales, and that happens in California. A lot of people already bought electric vehicles, and if they have solar PV, then you can charge EV, right, by their kind of net zero emission like PV power, solar PV power, which is great. And also like you're gonna increase the heat pumps, mostly probably powered by electricity, not by gas. That's another great sector in the related to buildings and consumers, and they improve the efficiency, a lot of those like that, and also some of the R&Ds. So that's what the US wants to do, and certainly makes sense for them. And there are a lot of other efforts globally. And for example, here's some news in Indonesia this year. I'm not, well, I think you probably know better than I do. I just copied this from kind of online sources. Say it's basically the net zero target is set right to be achieved by 2070, which is kind of 20 years later than most of other countries' targets. But certainly the other ministry, well, I don't know, kind of, well, sorry, you know better. So I'm just kind of read this, gonna to work with the state-owned electricity supplier. I guess that is a system operator in Indonesia, to basically to make this happen a little bit kind of earlier, to at least be close to that by 2050. And certainly you can see that it's different in different countries. For example, especially around the nuclear plants, right? So I think Indonesia here probably would build new nuclear plants, and that's also it's happening actually in the US and also in Asia. But a lot other countries probably don't have nuclear plants, and they don't have plan for that. For example, Germany, they won't do it, but they can use the electricity generated from nuclear plants from France. So a lot of those kind of nuclear power plants in France and the whole Europe, a lot of countries, they are also kind of interconnected, which means that you can form a market. While they are physically connected in terms of the transmission lines, then they can buy electricity from other countries. Then they form a kind of European integrated energy market. And that's what they're going to do in Europe, which is a different story. And here's a plan for Indonesia. I think it's very promising, and probably also rely on you guys, right, to achieve this as in terms of research, education, or industry practice. So what's the difference, right? We talk about a lot about like a net zero kind of roadmap, and what's the difference, why? And what transformations, right, we're looking for from what we have, for example, 2020, and also toward like the target, right? The year 2050, right? Among this during this kind of 30 years period, what we're gonna do. So here's a very kind of typical power system, right? Kind of architecture that we have for transmission grid and distribution grid to connect, right, the generations and the consumption, or the supplier and consumers, right? So mostly, even today, and actually it's changing rapidly, especially in Australia and other, or California or New York states in the US, that there are a lot of renewable generations. But let's say this is still the kind of the reflect the kind of the common kind of system in a lot of other countries, which you will have large kind of power plants and for large connected to large scale industry and in the transmission grids. And also you try to transmit, right, the power through the transmission grid into the distribution grid. And also the distribution grid that we see actually every day, right? Those feeders, and that is our like substations, and that is where we connect to, right? Our houses or our apartments, buildings, right? Campus, all connected, right? What's changing, right, is that we're gonna replace a lot of those kind of coal-fired power plants by renewable farms, especially like solar farms and wind farms, right? You see a lot of offshore or onshore wind farms. Each of those could generate like a 4 megawatt power, and to turn with those turbines would make it like a small power plant, like 40 megawatt capacity, which is quite big, right? And you see maybe hundreds of those, and that certainly supplies a lot cheap renewable, right, wind energy to the system. And also so also different countries may have different opinions on the renewable power plants, as I said, but it is still regarded as a renewable energy because it does not have any kind of carbon emission, right? At least that's good for climate change. But the other issue is about the security, nuclear security, and something actually is changing very or actually changing the energy landscape in the distribution network. That is, we gonna have a lot of different distributed renewables, and we have a lot of electric vehicles to charge. We have for a lot of batteries, right? So a much larger one, but still small, like a Tesla Powerwall, the kind of thing, or equivalent to the size of the electric vehicle batteries, right? Not the kind of iPhone battery, that's kind of too small. Smart buildings, smart energy management systems, that all in the distributed network, that make the system a kind of brand new system, right? That we need to actually how to run it, how to operate such a system, and how to plan for such a system, right? So that actually require a lot of different technologies, and especially from the perspective of data analysis and decision making. So that is all like AI can do, and that is also a very trending topic for research. So what's AI, right? So different people have different views again on what's AI, and this concept has been proposed in even early 50s, right, last century. So it has been evolving from some kind of try to kind of mimic, right, human decision making kind of thing, even from the very simple version, and develop to something like machine learning, statistical learning, right, database learning, all the things like that. And a lot of different kind of machine learning models proposed and used actually in practice. But more recently, maybe last 10 years, that because we have much better computational resources, from GPUs and different clusters, or data centers, right, that we have kind of enabled more advanced machine learning models, so-called deep learnings. And the other state-of-art research in the area of AI is try to basically to explain those black box models and also try to have like a machine reasoning like humans, right? So that's also something we can keep an eye out, which could be also used to change a lot of kind of business, right, and different sectors, especially here like energy sectors, how we run and operate the system. And you can see the other figure here, right, the one below. That is, we have a lot of actually data collection, right, from generations, from also consumers, right, which enable us to use AI to do better, for example, forecast, to also better analyze the consumer behaviors. And actually, consumers are at the center, right, at everything, at all business actually. When there's a demand, then there's a supply, right? So demands or the consumers are actually driving the change, right, of the system. So certainly demand is something we need to look into, consumers, and also to run the system, right, to operate the grid of the transmission network, distribution network, that a lot of like voltage issues, frequency issues, right, on this network that we need to also think about, have more data access and to analyze the data, to find solutions, and real-time communications, right, enable us to control things in real time, to detect faults, right, to also like they operate the lot of like the network configuration, right, and also the voltage control, and also the market built up on the physical energy system, try to better match the supply and demand through the market mechanism. So a lot of things happening here, and a lot of certainly AI tools, technologies could be used. Yeah, so here's another example showing some of the cases, right, based on like data. So if the data comes from like generation and demand, then we can do a lot of things for example, like to decide how to plan the system, where to sit the solar and wind farms, right? And also we can do the forecasts, right? We can forecast what the generation could be tomorrow, and we can forecast what the demand would be tomorrow, right? Or the next hour. So a lot of AI tools can be used for forecast. And a lot of AI tools can be used to make better decisions, right? And based on either model or combined with data to optimize the grid operation. That also includes a lot of things, and also the demand side management. And actually, manage the demand side is also part of the system management. So, for example, you can optimize consumers' consumption. You can optimize campus or like a community, or even a city, right, its consumption or generation as a virtual power plant, which is a virtual one, not a real one, or some small one could be called like a microgrids, right? So you can make like scheduling decisions. You can like operate the energy supply or demand. So yeah, like intelligent way using AI. So a lot of things that we can do, certainly, as long as, for example, we can collect data from some of the components or assets in the system, that we can do it better. So here, let me just go to the part 2 and part 3 about use cases, right, for smart consumers and for the smart energy cities. So those are the kind of 2 areas I'm going to talk about a little bit, kind of try to, cannot be in depth, but just give some different use cases to kind of give you examples that what you learned, for example, right, in the university, your unit about, for example, or the courses about AI or machine learning or data analysis, right, and other kind of mathematical courses as well. That would be very helpful to kind of equip you as like the future engineer or scientist in the area, right, to innovate and to address some of the real world problems in the energy sector. So first, I'm going to talk about AI-enabled smart consumers. So I bet you probably heard of some concept, so-called smart, what is it, like smart homes, right? Smart buildings, right? So a lot of those actually, so they belong to the consumers, right, in the system. As I said, consumers are at the center of the system, and they certainly want to make sure that the consumer is going to be analyzed, well understood, and how they can be also involved in the system operation. So here is on the left-hand side, that's a kind of typical house in the US or in Australia that you're going to see somehow the house is going to certainly connected to the outside grid, then we can call it like smart grid. And inside the house, it has something like certainly communication, right, to enable you kind of control a lot of different things. For example, the rooftop solar, and also the different smart appliances, and also the thermostats, basically like HVAC, the air conditioners for temperature control, right? For thermal comfort, and also smart meters to collect the data of you, how much energy you use at home, right? So based on all this, you actually can have some kind of app or like interface, right, to monitor what's happening, right, in your house, and to know in real time that how much you generate and how much you consume and things like that. And then you can do it better. You can manage your energy consumption, and you can manage when to charge your vehicle. And also you can look at the outside grid prices for you sometimes. Yeah, in energy kind of price that in Australia that you have a lot of different plan to choose. It's just like your data or like mobile plan. You can choose different plans. So electricity is the same here, that you can choose different prices. You can choose a little bit kind of time of use prices, basically means that different time you have different prices. You can have real-time prices, basically that price is going to change like every minute even. So for you, so you use electricity and that price is fluctuating every minute. So a little bit kind of scary if you use electricity too much at the high price period, they're going to pay a lot. But you can also shift your load to utilize, right, to kind of leverage the price spread. So usually at night, the price is pretty low and you can do a lot of energy intensive activities, right? So yeah, so we can have like a data collection from your home, or this is just a home example, and you can actually, we are doing that for buildings as well, for commercial buildings, and that's also for consumers. You can do that for industry. So to know how much you consume, and then to do a lot of AI enabled like use cases to improve efficiency, to reduce your cost, to improve your comfort, right? A lot of things that we can do. So here I'm just going through some use cases that will be very interesting for you. And these are all my research. So I'm going to give you 3 cases in the part of smart consumer. One is we can use AI to analyze energy consumption patterns. So from the data, we can actually have some insights into that, how we consume energy, right? And the other things that we can use AI to detect from the data and how, so what are your kind of energy activities, for example, at home? Well, it could be also used for buildings, right? And without actually see you from the data, sitting in front of the computer, doing some analysis, are going to know when you are cooking, for example, like that. And then we can also use like AI to kind of optimize your energy consumption to reduce your electricity bill, for example, like by 10 or 20%. And actually, some large industry like Google, for example, Google use AI to optimize their energy consumption, especially the computing, because Google have a lot of kind of clouds, right? Gonna consume energy to compute, and then they use AI to reduce their cost by like 10% something, which is huge actually. So we can also use AI to do that for your house and for different buildings. So I'm gonna talk about these 3 different cases that from my recent research. So first case is we can use AI to analyze energy consumption pattern. So what do we mean by pattern, right? So imagine over a day that you consume energy, and then you want to know, for example, how much you use, right? It's like a curve or it's like a kind of sequence or time series. If you have that, you can plot it. But if you plot it for one day, okay, that's it. So if you plot like for a year, and it's a lot of those, but you want to study like a group of people, like tens of thousands of people, for example, their consumption pattern, that we can't kind of simply visualize all those curves, right? We need to have some insights into, say, what are the patterns, right? How people use energy consumption, and any kind of underlying drivers of how people use energy. Probably different people use different energy differently, and certainly there are some interesting findings. For example, some existing work show that in a university dormitory, the peak energy use is at night and usually late night. That's because people are like just probably play kind of video games, something like that. And but that could be very different to like other senior people who like sleep usually earlier, right, and may have the peak in the daytime. So that could be, the patterns could be very different. So here we use the smart meter data, right, collected from different houses, and then we do a little bit kind of trick to remove to eliminate the impact of noises and outliers, things like that, and focus on the shape. Basically, the shape reflects, right, the pattern of energy consumption, and then we do a little bit kind of processing, right, on the data, and to basically find different kind of approximate levels of different consumption over different time. And then based on the processed time series data of a lot of users, for example, and over multiple years, right, we do machine learning analysis, for example, like clustering. So we cluster all these different time series and consumption and over years, and to identify different patterns over weekdays or weekends, right? And then we can see actually, we identify, for example, here, 7 typical patterns that each of those represent like a different shape of the load. And some you can see you have dual peaks, a peak in the morning and a peak in the evening, basically reflect that people in the house cooking, right, in the morning, probably like having a coffee or some other, or tea, right, using curdle, or using like or cooking like to have a hot breakfast. And also in the evening, people like also cook dinner that consume a lot of energy. And usually for people working right back home in the evening, that is when you start to use like lights, right, and things like that. So you have another peak, but sometimes different. The peak appears pretty late at night, so that reflects some different lifestyles or like a consumption pattern, right? Sometimes you have the peak in the daytime, so that happens a lot in the kind of weekdays because people stay at home. But for weekends, people stay at home. But for weekdays, probably don't have that. So we can see a lot of actually insights from this clustering analysis. And to take a further step that we want to know, right, whether different people consume different energy differently. That's also a very interesting topic that we had some recent studies. So we collect, for example, demographic data about, for example, people's age, right, income and education, and the house square footage, things like that. And we try to map, right, this information with different energy consumption patterns, and to see whether some of those factors, right, would lead to some of the load patterns, right? Basically, we try to find out different people may really have different behaviors, and that's something so we don't see a lot actually in the studies, but that provide a lot of insights for and also to make sure, for example, energy equity. So if you design energy tariffs, right, you want to make sure that different users, some of the users will not be like in a disadvantage, especially when those guys are vulnerable groups, for example, disabled people, or like senior people, or sometimes low-income people, right? So you don't want to hurt those different like social groups. So that's going to also provide insights to make sure that the energy system serve people right in an affordable way and also in a fair way, right? So that's some of the motivation with this kind of research. And then we can build like a deep neural network, right, to input different people's demographic features. And through this network, deep neural network, we're going to find out the distribution of their load patterns and try to identify whether some of the social group would have like a big kind of portion of their energy consumption in one of those load patterns, right? So these are later we do find some interesting kind of insights. So certainly our model, like a deep neural network, can categorize that highly nonlinear relationship, right, between different people's background and their energy consumption patterns, and compared to the ground truth. And other different regression models won't work well in this case. And we find quite interesting, so these are C1 to C7, right? These are like the different patterns of energy consumption. And we do find, for example, like elderly and consumers, they do stick to very routine activities, which means that you're gonna have like some of the dominant load patterns, which means which count for maybe like over 60% of their energy consumption would belong to one type, and from the senior people. So that's some, which certainly means that senior people may have like more like a regular, like a lifestyle and routines every day, maybe retired, stay at home every day, would look like similar to each other, right? But other households, for example, with children, usually would have a peak during the evening time, because that's probably the time that they pick up their kids back and also start to cook, right? And have some family activities at home that consume energy. So that's also some of the insights, quite interesting. And a lot of things like that we can do from AI, right, to basically find out how you consume energy and how different people consume energy differently. That's very interesting. And we provide insights that are not actually seen right in the past. And also seasonal consumption could be also different, right? From like spring, summer, and to fall to winter, and each different season, people use different energy differently. So here's on the left-hand side, you can see each dot, right, a color represent one type of a load pattern. And some users, they have very load patterns over 4 seasons. They don't change at all. And some people have very seasonal patterns. So each season you're going to change from one pattern to another or another season. That's also quite interesting. And we also try to, then you can also use AI, right, to get this kind of results, to provide insights of how people's energy consumption changes over seasons in a year time, and also what are the kind of dominating factors that would basically explain why people change their behavior over seasons. That's also quite interesting. So we do find that high-income people may have a little bit more diverse energy consumption over seasons, which probably means that they use a lot of other kind of appliances like extensively. For example, in the summer, they always turn on their ACs, for example. In the winter, they have their heatings on always. Right? They don't care about, for example, the electricity bill. That's just a small money for them. So actually, different people do have different behaviors that we can get insights from like AI-based analysis. So another case that is about we could have like energy activities being detected, right? Okay, so I'm gonna have for 10 minutes to finish everything. Okay, it's pretty challenging. Kind of prepare maybe a little bit too much here, but okay, let me just be quick. Okay, so we can do actually also the you can see the we can detect what you are doing at home, which sounds a little bit kind of creepy based on your energy consumption data. But the privacy is another issue. If we can detect, right, then we probably can find a way to protect that being detected, right? So that's actually kind of for the two sides of a sword. But we do want to know whether we can detect that. So based on the energy consumption data, right, use different energy for different things, for like doing laundry, to cleaning, to cooking, right, for like TV and things like that. So without installing like sensors. So for example, we define two different tasks that we can detect the activity, or we can disaggregate the consumption for certain activities based on the smart meter data. The black curve is the aggregate load we see. We can't see anything else, just the load from the meter. And then we try to understand whether we can do it. So, okay, so that the task is quite simple. We can also use AI, right, to have different features for machine learning, frequency domain features, time domain features, statistics, right? A lot of different interesting features that we can extract based on the data. And we can also have the time calendar features as well to put into different machine learning models to train and to output the activity detection, whether there's cooking, things like that. So if we focus on, for example, food, cleaning, and the EV charging, that we do see that some of the machine learning models can achieve very high accuracy, right, of detecting people's behavior at home using smart meter data. They can also use like deep learning, like deep neural network, and transform a lot of different state-of-the-art machine learning models to further estimate how much you consume for each of the activity, how much you consume for cooking, for example. It's just like your credit card, like a bank statement, right, shows that how much money you spend for restaurants and how much spent for like entertainment. For example, you buy a video game, things like that. So we can also do that for energy, how much you consume for different like activities. And our method does show that we improve the accuracy, right, of estimating people's energy consumptions estimation compared to other different models. So the other case I'm going to briefly introduce, that is instead of say analyzing people's behavior, right, without doing a kind of intervention, actually we can do a little bit kind of optimizing to help people to reduce the energy bill, for example, to get a reward from some programs called demand response. Basically, that is you want your supply to satisfy the demand, but sometimes your supply is too expensive for the demand, or demand is too high. You want your demand to be reduced. Okay, that's a very straightforward idea, but you need to pay the users for doing that to reduce energy consumption. So we can actually use online learning, different machine learning tools to do that. So you can send a signal to users saying that I'm going to pay you $1, how much you're going to consume, reduce. And iteratively, you can learn people's like a willingness, right, of reducing their load based on different economic incentives. And we can do some theoretical like analysis in that this kind of iteration can gradually lead to the optimal pricing and optimal demand response in reducing people's consumption and for people to get a reward. And some of the analysis shows that initially there's error in your estimation doing pricing and the response from users in reducing load, but gradually you're going to be very accurate compared to the optimal one and the online learning one. So which shows that machine learning is a powerful tool to understand people's kind of a willingness, right, to reduce their load, to also enable them to be smart consumers. And also the other case, very briefly, that people have electric vehicles in the community, how we can manage electric vehicle charging. So we can build, you can see here, quite complicated AI models, but don't worry about that. It's just some of the models we use.
Excuse me, Dr. Ho.
Yeah, sorry.
The presentation session is left 5 minutes.
Yeah, 5 minutes, right? Yeah, good. Okay, gonna finish everything in 5 minutes. Yeah, so it's quite kind of complex model, right? But it doesn't matter. So when you learn that, you do know how to do it. And then we can use it to kind of coordinate electric vehicle charging to reduce the peak charging, and also compared to other state of arts. And we do see that we achieve a good performance in reducing the computational time and also to reduce the cost for all the EVs. Okay, so last 5 minutes or maybe 4 minutes for the AI-enabled smart energy city. Okay, you see here, it's a small city, you have a lot of renewables, a lot of smart buildings, smart consumers, and electric vehicles, all things like that. How you can operate such a system, right? It's so different from the traditional one that we have today. And here I'm just to give you an example of what we do here on the campus. The campus is a smart energy city. You see that there are like, we have for yearly, maybe, I don't know how many, maybe certainly more than 40,000 people on campus, right? So certainly it's a small town or a small city. Now we have different buildings and we have different solar panels, that we have energy batteries, we have EV chargers on the campus. A lot of activities, retailer, right? Sports, right? Residential services to students, right? So how we can operate that? Basically, it's a microgrid, right? So we want to have a microgrid system on campus that can operate that. And so, for example, we can do manage the voltage when there's PV, and we can do a forecast of PV. We can do optimal operation for the battery. Then we can do a coordination of all different energy resources. We can do smart building control, right? Optimization of load, and a lot of things like that. So here we do, for example, the building efficiency stuff on campus. We try to reduce the energy consumption of buildings and how to use the AC smartly, right? And also we try to, for example, enable some flexibility in buildings, right, for demand response. And also we try to operate the campus. We have a large battery and more than more than a megawatt hour capacity, which is big. And we have also 3 different charging stations on campus, how we optimize EV charging, coordinate that, right? So all this actually requires a lot of AI tools and to aggregate all these different resources to provide smart energy management and further provide services to the Australian energy markets, at least locally. That is a roadmap we're going to do. And a lot of transactions, things like that. And also we can enable human in the loop AI on campus to understand how people use consumption and how we can change people's behavior, and to satisfy people's need on campus. So a lot of things we are doing, and also we have a lot of initiatives and work with a lot of industry partners. We even have a control center of energy for our microgrid, for our smart energy city on campus. So if you get a chance to visit us, we can show you around of this control room. And again, basically last slide, that is our capacity of Monash in this area for consumers, right? Decision-making, energy trading, visualize consumption, understand people's behavior. And also on the grid part, we do optimization for the power system operation, distributed optimization for the DRs, machine learning for forecast, right? Stability analysis using deep learning. Then to build smart energy system, basically smart energy city for the campus that can be like a example or like a kind of demo, pilot project for other smart cities, right? Energy cities to use AI, machine learning, a lot of things, make it smarter. Okay, that's it. That's the end of the slide, and finishing perfectly in time. And so if you want to know more about our research, you can find us on the IT for Sustainable Energy thing on our website, and also Monash Energy Institute, and also our university home pages, right? So you can find a lot of more research and activities happening here. Okay, that's from me. Thanks a lot.
Okay, thank you, Dr. Halwan, for the best presentation and insightful knowledge about this presentation today. In case 3 about optimizing energy consumption, I very interesting to implement it as soon as possible. It's my challenges for implemented. I remind again to all the participants, the questions will be merged into one time after the two presenter done about his presentation. For the participant, you can ask the question with the feature raise hand on the meeting or ask the question on chat box. You can ask the question with two languages, English or Bahasa Indonesia. Moving right along, we have the second presenter is Mr. Eduardo Jonathan Sutanto. Mr. Jonathan is Bachelor of Renewable Energy Engineering, University of New South Wales Honors, Class 2 Division 2 with thesis topic Hybrid Wind and Solar Research Mapping. Now, Mr. Jonathan worked on PT Surya Utama Nuansa Sun or Capstar Capital as Head of Business Development or Engagement Manager. Mr. Jonathan had publication on renewable energy sector. The title is Hybrid System Solution for Off-Grid and Rural Energy Access in Indonesia, November 2017. Submitted paper and presented in the International Congress held by Institut Teknologi Nasional or ITENAS in Bandung, Indonesia. Mr. Jonathan had two more projects like in Sidrap, 75 megawatt wind farm, first utility scale wind farm in Indonesia, 2014 and until 2018. Verified wind research of the site with owner and lenders engineers. Designed the turbine layout and perform layout optimization. And Mr. Jonathan had 12 certification and training like certificate VSP user, certificate grid connected PV designer, PV training, training course, solar PV technology, project engineering optimization and risk mitigation, and many more. So without any further ado, this is the second presentation with artificial intelligence built a national capital city with renewable energy. Please welcome Mr. Jonathan.
Hi, everyone. Hi, thank you for the kind introduction, Iqbal. I would like to first thank everyone for the opportunity to speak here. Now let me, get into the presentation. So let me share my screen. Okay, yeah. So, let's start without further ado. First of all, I would like to discuss a little bit of a global movement towards renewable energy. Now, you can see that this is a research done by Bloomberg back in 2020. Now, they're saying that the global electricity demand will actually increase by 60% come 2050. So that's about 30 years from now. And like 75% of the demand will actually be met by renewables. Now, this is, you can see here that there is a really big shift here from fossil fuels, which accounts for 64% of the market share today, to 20% by 2050. This is especially apparent for developing countries, such as Indonesia and other countries in Southeast Asia that will actually output a lot of energy by 2050. Now, I want to focus a little bit more on Indonesia because we're all Indonesians, and I want to just give you a bit of a highlight on what's happening on the ground here. So basically, in 2019, these numbers actually should be updated, but back in 2019, Indonesia's total energy mix actually comes from fossil fuels, and that's coal, oil, and gas. Oil is actually still a very big portion of the primary energy supply. Now, there are actually three main contributors to this fossil fuel usage. The first one is power, transportation, and industry. Now, the power sector specifically is only 11% of actually renewable energy, and the rest still comes from fossil fuels. Why this is happening in the past is actually, from our analysis, it comes from several factors. Now, first of all, there's unfavorable incentives for renewable power so far. So when compared to other countries in the region, in Southeast Asia, for example, in the Philippines, in Vietnam, The government really incentivizes renewable energy power projects by providing something that's called a feed-in tariff, where developers, project developers are given a set incentives to actually build the projects. Another factor is actually unbalanced risk allocation. So this is actually related to financing of renewable energy power projects, where risks in terms of, for example, currency risks and construction risk, all of this actually sits on the independent power producer or the project developers, while the government, in this case, PLN, is accepting risks. Another thing is also, as I mentioned, regulations and procurement standards that are not clear as of now. Foreign developers, for example, are still quite hesitant to enter into the Indonesian market because there is still not much clarity. Now, this last one is more geographical, and I think it comes as something that is in Indonesia's nature, which is we're an archipelago country. So we have a distributed grid with multiple small grids. For example, there is the Kalimantan grid, there's the Java Bali grid, there's the Sumatra grid, and also there are multiple small grids, especially in eastern Indonesia. Now, this is a problem because then you cannot build a solar or a wind farm that's like very close to the grid, and at the same time have a sizable scale to actually achieve the economy of scale. Now, fortunately, this is not all doom and gloom for Indonesia. Now, back in 2015, actually, our government made a commitment in the Paris in COP21. In Paris 2015, to actually reduce GHG emissions, greenhouse gas emissions, by 29% below business as usual. So this is a very ambitious commitment, and in order to realize this commitment, the government has made another commitment, especially in the power sector, to actually achieve 23% renewable by 2025. Now, this is a very ambitious target. As I mentioned in my last slide, Indonesia currently only has 11%. So it's a long way to go, but we're all very optimistic, and I will tell you why and how we can get there. So, this 12% difference actually accounts to approximately 10.5 additional gigawatt, and then that's a very, very big number. So so I want to then touch base a little bit on sun energy and what we do. So basically, we are at the moment the #1 CNI solar developer in Indonesia, with a growing regional project portfolio. So we don't only invest in Indonesia, but we also invest in other countries in the region. So as a company, we actually have several arms. The first one is our commercial industrial arm, which is sun energy itself. And so basically, commercial industrial, what we do is we install solar rooftops on top of industrial electricity users to actually reduce their electricity bill. And then we also have Santera, which is a residential company, and they do solar panel installation for homes and like home offices across Indonesia. And then the last, this is more of a newborn initiative. It's we have Sun Mobility, which is basically focusing on electric vehicles and electric vehicle charging all across Indonesia. And the last one, and actually this is quite interesting also, is a new initiative we established called REC Indonesia. It has something to do with renewable energy certificates, which I will touch again later on. And actually, on the right-hand side here, this is sort of our portfolio going forward. So we plan to go into other markets such as Taiwan, Vietnam, and actually we just entered into the Australian market by signing a deal a couple of days ago. So we're very aggressive, and we want to do a lot in the solar space. Okay, basically this is what we do. So we offer not just solar rooftop, but we also offer financing, which a lot of times is the main issue for renewable energy penetration in Indonesia. So we basically offer zero capex upfront for the customers. And yeah, we basically integrate solutions as a custom-made solution for the customers. So I'll move on. Yeah, so this is basically just just what our contribution is to the environment. Basically, at the moment, at the time of this presentation, we're at about 75 megawatt peak, and so this offset about 2.4 million CO2, which basically, and then this is our ambitious target by 2025. We plan to actually install about 1.9 gigawatts, and this is we plan to emit. Oh no, not emit. Sorry, but and offset 62 million carbon dioxide emission. So I think then, yeah, this is how we actually do it in Indonesia. So a little touch on our business plan and basically business model. So what we actually do for our commercial and industrial clients. So basically, these are clients such as Unilever, and then Shell, and then some other big names, Astra, where we actually install solar panel on the roof without any investment upfront, and we call that the PBR option, which is what we call a performance-based rental. Now, why this is interesting is because, well, I personally think this is sort of like a no-brainer business model. So basically, we provide the solar panels to the customers. They don't have to pay anything upfront, but what they pay to us is actually a reduction on. We basically give them a discount on the business tariff that they usually pay to PLN. So yeah, it's basically they don't have to pay anything, and then they get a discount. But the catch is they have to do a contract with us for example, 15 to 25 years. That's the only catch, So yeah, this is sort of our bread and butter commercial and industrial solution for our clients, and we're very aggressive. We're now the biggest provider of this service in Indonesia. So next, actually, is now this is more relevant, I guess, to this webinar. Now, what we have also developed over the years is, a mining industry solution. So, as you know, in Kalimantan, for example, there is a lot of mining companies, right? So, what these mining companies have in problem is they don't have electricity because they are located in very remote places. So they use diesel. Diesel is very expensive. It's also a risk to actually transport the diesel from the port to the mining site, and then also it's a lot of maintenance with diesel. So we brainstorm with some of our clients, and then we had a lot of discussions on this. And basically, what we are doing is we are implementing a hybrid system whereby we are hybridizing their diesel genset with a hybrid controller, and then with a renewable energy source to basically reduce the diesel consumption. So this is I would call this a smart power integration that actually increases literacy in power generation and consumption data for the mining companies. Yeah. So this is actually something that we are rolling out at the moment. It's actually under construction in Kalimantan Timur. So yeah, I'm very looking forward to that. But unfortunately, because it's still under construction, there's no pictures yet. Yeah. So another thing that we are working on, and this is maybe in the next few years, is with 100% renewable energy solution, which is the Sultan Storage, where instead of diesel, we will be utilizing batteries to provide power when the sun isn't shining. This is a bit more ambitious project with the cost of batteries and battery storage, but we are working very hard towards realizing this to actually meet the net zero commitment also, as described by Dr. Wang before this. So actually, yeah, so this is what we call a solgen for our mining and remote location solutions. But we're not stopping there, actually. So Sun, as a company, we're very innovative. We like to try new stuff. And this is our vision of the future. So the first one on the left is called a VPPA. This is slightly different than the virtual power plant that was described previously. But VPPA is basically virtual. We engage with a lot of B2B clients. So basically, as I mentioned, the very big MNCs such as Astra, Honda, Unilever. So all these people, they have global commitments actually to be RE 100 to actually generate most of their electricity usage from renewable energy. Now, there is, especially in the international market, there is a huge trend towards what we call a VPPA, which basically is a selling and trading of RECs, what we call renewable, and the generation of that renewable energy is offsite. Now, why this is interesting is basically, for example, a company that does not have the sufficient roof space to actually install solar panels compared to their energy usage. I can give you a quick example. Data centers, they're very energy intensive. They need a lot of power to actually to cool the system down. That on their roof, it's a very small establishment. They mostly on their roof, it's more of an exhaust for air conditioning. So they turn to this solution with renewable energy certificates. And so basically, they can buy electricity offsite. So they can, for example, the solar power plant is in Kalimantan, and then their factory is actually, for example, in Jakarta. And so they can buy the renewable energy electricity from Kalimantan from Jakarta. So it's it's a very it's a sort of like a future tech, and actually to settle some of these transactions and to ensure that it's credible, people actually use blockchain technology, which I will touch also a bit later on after this. So this is actually a very trendy thing now in more open markets such as Australia and in Europe, you see. But Indonesia, this is still unprecedented. So it hasn't been done yet. The next initiative that we're working on is actually on power wheeling. Power wheeling is slightly different, where we are basically using PLN's transmission lines to actually send power. So basically, for example, we have a factory in Bali, and then so this factory is say in Bali, and then our generation side, for example, we have a land in East Java. So what we can do is we can transmit the electricity from East Java using PLN's lines, PLN's transmission lines, to that factory, and then we pay a leasing fee to PLN. Now, this solution actually has been around in PLN's mind for a very long time also, but then it has not been implemented yet because of commercial negotiations. So unfortunately, it hasn't been done yet. But at Sun, we are also looking into this option to basically provide solutions for our customers. Yeah. So I'll move on now. Okay. This is what another initiative that we are working on. As I mentioned, it's from our REC Indonesia, basically Renewable Energy Certificate Indonesia. Now, this is the first blockchain-based REC trading platform in Indonesia. Now, what this REC does is, as I mentioned, a lot of companies, they have commitments to go green, and they don't have enough space or they don't have enough capabilities to actually generate power through renewable energy. So what they do is they purchase this renewable energy certificate generated from renewable energy power plants, in the country. It needs to be, it's very country specific. So, for example, you cannot buy power from Singapore for Indonesia projects. So yeah, then basically it's what we're doing is we're establishing this trading platform where people can actually buy and sell this RECs. At the moment in Indonesia, there is a high supply issue. Basically, there's not enough renewable energy power plants to actually supply these RECs. But there is a lot of demand from multinational companies such as Facebook, Google, Amazon to actually buy this renewable energy certificate. So what we're doing is we're making the platform to connect between the supply and the demand side. Yeah. Yeah. So basically, another slide that I have is on what we're doing as part of our CSR program. But not only that, it's also we see that we can actually it's actually some of these initiatives, they are commercially viable as well. So what we have done is a brackish water reverse osmosis program, where we provide clean drinking water for villages in Eastern South Tenggara using this technology. So basically using solar power to produce clean water. And then we're also doing a lot of initiatives on cold storage, for example, and then rural electrification. And I think in the future, what we want to do is electrify schools and also hospitals around the country using renewable energy. But then in order to achieve all this, it will not be possible without the technology. So this is something that we need to work on and increase focus on. Yeah. So another thing that I want to actually highlight here is some of our rural electrification projects. I will call this as technology leapfrogging. Basically, these rural villages, actually this one is in East Kalimantan, didn't have electricity in the past, but now by us installing solar panels, that they basically leapfrogging the conventional fossil fuel technology by going straight into solar, straight into renewable energy 100%, using batteries and existing solar panels. So yeah, I think the future for Indonesia is, especially for the villages that are currently unelectrified, is actually this technology leapfrogging by going straight into renewable energy. Okay, well, actually, that's a very short presentation for me. I think I'll be very happy to entertain the questions and answers later on. So yeah, I leave it back to Pak Iqbal.
Okay, thank you, Mr. Jonathan, for your insightful knowledge about your presentation today about artificial intelligence build the nation capital city with renewable energy. I think renewable energy is very important for the future energy, especially in Indonesia, where there is already momentum. The latter on October 31 in Indonesia will be held at the 2021 United Nations Climate Change Conference, or COP26 in the UK. Okay, I think let's move on to Q&A section. To all the participants, you can ask the question for the two presenters, Mr. Jonathan and Dr. Hawang. You can raise hand or ask the question on chat box. Okay, the first question in the chat box with Aditya Niko. Greetings. When the world agrees taking this step, what approaches may be available to make developing countries, especially Indonesia, understand the importance of building synergy between government policy, research finding and results, and business and industrial product for smart city? Thank you, sir. For the question one to Mr. Jonathan, you can answer the question from Aditya.
Yeah. Okay. Thank you, Aditya, for the question. What approaches might be available? Okay, so there's actually a lot of approach, I would say, especially if we just a very simple one. I think the easiest to do is to do a comparison, for example, with other neighboring countries in Southeast Asia. For example, Vietnam is a market that I'm quite familiar with. In Vietnam, there is actually a lot of support from the government to install more renewable energy. Basically, what they do is they set a price to so that there is a lot of clarity in the regulation. So they set a price for the developers to actually buy the. For the government to buy the solar electricity from. And that's very clear. So, I think a lot of investors are very interested in investing in Vietnam because of that. There's also tax incentives, to basically make the projects in Vietnam very effective. Also, I think that it needs to be a link between, the business developers, the commercial side with the banks. For example, local state-owned banks such as Bank Mandiri. I just give you an example. They're very keen on providing financing for renewable energy, but at the same time they are still not very familiar with the technology. They're not very up to date with the current happenings in the world. So yeah, it's a lot of effort to actually raise awareness, build competence. But I think there needs to be a lot of socialization, such as having this webinar with all stakeholders, including government, including the banks, including research and academia, and of course businesses to actually penetrate more renewable energy to the electricity grid.
Okay, thank you, Mr. Jonathan. I think it's more reliable about the country as Vietnam. But Indonesia have to Ministry of Research of Energy in the policy in KSDM number 49, years 20 and 2018, when the export-import in challenges is 100% to export-import. I think it's more policy like to improvement the PV system, especially. Yeah. Yes.
Yeah. So things like that really improves the industry. So very helpful to have these policies.
Yes. Okay. Thank you. The answer from Mr. Jonathan. The answer to the speaker one, Mr. Dr. Hawang. You can answer the question from Aditya Niko about the importance of building synergies between government policy, research finding, and research, and business and industrial products for smart city. For Dr. Hawang, you can answer the question from Aditya. Okay, I think Dr. Hawang is not ready for the question, the first question. I think let's move on to question number 2 from Farkas Fauzan. Good morning, sir. My name is Farkas. I have a question. What needs to be done to apply artificial intelligence to industrial or residential to controlling the electricity use? Do we need to think about the law about electricity that apply on the country too? Thank you, kindly, sir. To Mr. Jonathan.
Okay, yeah.
Yes.
Thank you, Faras, for the question. It's a very good question. Of course, we need to think about the law. Yeah,
Yes.
it's impossible for us to do anything illegal. So I think the law about electricity is very important. In Indonesia, there is a really strict law about electricity and electricity selling, but it's actually governed in our Undang-Undang Dasar 1945. Yeah, so it's a very strict industry to be in. Now, I think regarding artificial intelligence, specifically for residential industrial sectors, so actually at SUN we are already implementing measures to apply artificial intelligence. There's the technology currently that we are using is already equipped with artificial intelligence. Basically, our inverters, our the I forgot the name of the component, but yeah, basically there's a lot of monitoring that's done by the system itself. So it's flagging out errors, and basically it's making our lives a lot easier because. So basically, in for our clients that's in the industrial and residential space, it's tiny projects spread out over a lot of locations. Right? And it's not just I'm not just talking about just Java. I'm talking about Kalimantan, talking about Sumatra. So there needs to be some sort of artificial intelligence to actually monitor all these power plants and feed that information to us. You see, so basically. Fortunately, we already have this in all the equipment. So what we're doing is we have a set team that's in our office, and they monitor all the ongoings. And if there's any issues, there's any concerns over the power plants, then it will tell us, and then we can tell our people on the ground to actually take a look at the issues. Yeah. So it's very important to have at the moment, and I think it going forward it will be more and more important, especially as we grow, with more solar panels on the roofs.
Okay, thank you, Mr. Jonathan. I think I want to tell us about my experience about this component of PV system. Because I part a little part of the program Ministry of Research and Energy, GIRILIA, Gerakan Inisiatif Listrik Nasional. Yes, I think the PV system is so important for penetrasi about this renewable energy 23% on the 2025 in Indonesia, because PV system is more flexibility about the implemented or installation on government, industrial, residential, or rural, and implemented AI on the renewable energy. We can improve that through about this component in PV system like inverter, maximum power point tracker, or MPPT, or the smart grid to maximize export, import, and feed-in tariff in USA like that. About the we can improve like me as student, we can learn more to improve the technology about AI in renewable energy. But the law of renewable energy, Mr. Fakas Fauzan, you can see about the ministry policy on ministry policy number 49 on 2018. He explained about that the rule and law about renewable energy sector. Thank you, Mr. Jonathan. Let's move on to question number 3. You can you can ask the question like on mic. You can first raise hand or chat on chat box in Zoom meeting.
I think there is 2 questions from Faras. Yeah?
Oh, Faras again, Mr. Jonathan. Okay, I can. Okay, good morning, sir. My name Faras. I have a question about renewable energy. How many years will it take for renewable energy to overtake conventional energy fossil in Indonesia, especially with the current conditions in Indonesia as a danger in building and maintaining renewable energy plant compared to conventional fossil energy? Thank you, sir. It's about the compact about renewable energy on the conventional energy, like Kalimantan is coal energy, is so much coal energy.
Yeah. So that's also a good question. So, how many years will it take to overtake is a very good question. Well, as Dr. Hawang initially mentioned, there is a lot of commitments globally that has been happening actually over the past week only. That governments are saying they're going to be net zero. Net zero means there'll be zero carbon. So basically, by then it'll be renewable energy will be overtaking conventional fossil fuels. Of course, this is not easy, but a lot of countries are saying by 2050 they're going to be net zero. So yeah, it's going to be an interesting few years coming. So yeah, I think we will need a lot of jobs in the renewable energy space to actually realize these commitments. Now, actually, on the next question, dangers in building and maintaining renewable energy plant. Actually, it's for example, solar panels are very easy to build and maintain. Construction for a typical like a coal power plant can actually take up to 2 or 3 years. Now that depends on a lot of things. But for a solar power plant, you can build it in 3 months. So it's very simple, very easy. It's like a plug and play sort of thing. And then actually in maintaining it, it's also very, very simple. I can give you a funny story. Back when I was in Australia, in Australia, labor is very expensive. So there is a solar farm that I visited, and basically how they maintain the solar farm is they basically put goats there. So basically, because if the grass grows too tall, it will block the solar panels. So what they do is the goats just eat the grass so that it doesn't grow too tall. So it's a very simple technology with very simple maintenance. In sun also, we try to minimize maintenance basically because it's already working as intended. So basically, but I think like every 6 months we have to clean the panels. We just it's just a spraying of water. It's very simple and anybody can do it. So yeah, it's actually much better than conventional fossil energy.
Okay, thank you, Mr. Jonathan. I think it's true, but in Kalimantan, coal energy is challenges in Kalimantan because the coal energy have many much. But I think the Kalimantan, especially is Kalimantan, example like Badek LNG, natural gas liquefaction, that implemented about PV system like 3 megawatt peak on the Badek LNG. I think that's the industrial in Indonesia. I think must the transition about renewable energy. And the renewable energy can choose is the PV system because that is simple, flexible, and just only plug in the PV system. And then the PV system, true about the answer of Mr. Jonathan, the warranty about the PV model is 25 years. But the challenges is what can do the waste of PV module in until 25 years. What can do? We can improve that waste the energy PV system until the production is quarantine is end. Thank you, Mr. Jonathan, for the answer. Next question to the participant. You can ask the question until on mic. You can raise hand or you can ask the question on chat box. Okay, for the participant, you can ask the question to Mr. Jonathan or Dr. Hawang. You can on mic or raise hand or you can chat the ask question on the chat box. Okay, from Fairly. Good morning, sir. My name is Fairly. I have one question about renewable energy. Why is the PV system more suitable to be used as renewable energy in the future? Thank you kindly, sir. You can, yes.
Okay, thanks for the question, Perli. Yeah, so based on, I have actually looked at a lot of other renewable energy sources. I've done hydro, I've done wind, and I'm now doing solar. Now, why solar? Maybe then I would like to think it's not just solar. It needs to be a combination of everything. Solar on its own is very difficult because it only operates during the day. During the night, there's no power, right? There's no sun, so it needs to be in combination with other technologies. So I wouldn't say that it's just solar, but I can maybe explain a little bit about the other renewable energies. So, for example, hydro. Hydro is very costly. It needs very site specific. So some of the hydropower plants in Indonesia are actually constructed in a protected forest or a hutan lindung, and the permitting for that is very difficult. It's environmentally it's also not very good. Because basically what you're doing is you're cutting a mountain, and then you basically have to make the flow in such a way that it is in according with your design. And then another, for example, wind. Wind is also very site specific, so it may not be constructed anywhere. It needs to be in a region with very, very good wind. And in Indonesia, there's only very limited space. I mean, not space, places with very good wind sites. So at the moment, Indonesia has a lot of potential for solar, especially in eastern Indonesia, where electricity is still scarce. So yes, and solar is very modular. You can do 1 kilowatt system up to 500 megawatt system. So it's very very flexible, easy to install, as I mentioned, easy to maintain, and there's a lot of resource, especially in Indonesia.
Okay, thank you, Mr. Jonathan. I think I little adding about the PV system. PV system have the two topology, on grid, on off grid. For off grid is to solve about the system is generate electric with the photovoltaic when the sun is rising. In the night, we can with the topology of grid with the battery system to generate the load of the home. I think the PV system is more improve their technology about like inverter and PPT, like the hybrid. The PV system is like generate about to electricity like diesel or PV system like that. Then I think the quality of PV system is more than renewable energy others. Okay, thank you, Mr. Jonathan. Okay, to question answer to Mr. Dr. Hawang. Can you answer the question fairly about the renewable energy like PV system? Why the PV system more suitable to use renewable energy in the future?
Oh, sorry, ask me, right?
Yes, Dr. Hawang.
Sorry, is it in the chat or somewhere?
In chat, Dr. Hawang.
Yeah, sorry, it's about disadvantages of using renewable energy or some other problem. I just try to
about PV system more suitable to be used as renewable energy.
About PV system.
Yes.
And in what aspect? Because I didn't see that. I just to try to understand the question.
I can write again in the chat.
Oh yeah, that'd be great.
Yes. Why is PV system more suitable to be used as renewable energy in the future, more than renewable energy system others?
I see. Okay. Yeah, that's a good question. So there are like a handful of choices, right, of different renewable energies, including like solar PV. That's one technology, and there are other like wind farm and things like that, right, and also some bio, right, and it's kind of for and even like the ocean, like the wave, right? Entire energy, and so all kind of different forms, they all counted as renewable energy, right? So, but why the solar energy is developing so fast? I think there are a couple of reasons from the technical perspective and also from the kind of market perspective. So, solar energy actually compared to others are, well, let's say solar doesn't matter, it's a wind farm or solar farm, or it's like a rooftop solar. It's more predictable, right? In terms of, you know that sunrise and sunsets, and then when there's a sun, you have like outputs generation right from the solar system. But the other technology, like the wind and other things, are not. So if you look at the, for example, generation of wind farms, it could be very, very different from places to places. So it's less predictable in terms of solar energy, and we certainly want something to be, say, more predictable. And also, it's also easy to install, right? So you rarely see actually small wind turbines or things like that, or for people living in the lands, right, far away from ocean, that probably don't have wind as well. So that actually makes wind energy less actually that kind of widely adopted, especially by end consumers, right? As like households, buildings. So solar energy is also certainly better, and also in terms of markets. So that PV, right, technology actually, I think it was invented in Germany, probably. I need to double check. But then later, kind of the United States, right, make it a little more like on the market, and people gradually, right, adopt it. And then later, the manufacturing of the PV panels, the price drops dramatically, and because of the large capacity of manufacturing in China, that make the price actually decreases maybe to like 10% of the original one, or even less than that. So it make really affordable. So in that sense, people also would like to adopt the kind of the kind of more affordable, right, technology, and PV is one of them. So that's the reason we see a lot of solar PV than other wind or other things. And yeah, I hope that, and also that's the future. Unless there's another technology groundbreaking we never see, or it's become mature in the future, and that probably going to replace solar. But from now on, that we still think that PV is the most will be the widely used energy for in the foreseeable future. Yeah.
Okay. Thank you, Dr. Hawang, highlighting about that. Dr. Hawang's statement about generate the starting energy. The PV module is more than efficient than renewable energy others. And then for the first step for implemented or installed the renewable energy in geographical, we're gonna see geographical like global horizontal radiance in East Kalimantan, like that 4.2034 kilowatt hour per meter squared. That is for that potential about implemented PV system in East Kalimantan, about the nation capacity. Okay, thank you, Dr. Hawang. Let's move on to question number 4. Dear Fatmawati, good morning, sir. My name is Fatma. I have one question. What are the advantages and disadvantages of using renewable energy? Okay, to Mr. Jonathan, can answer the Fatmawati question. I wrote the chat box again about the question.
Okay, thank you.
Okay.
Okay, so yeah, advantages to renewable energy. I guess I think number one that we need to mention is that it's clean. There's no emission. It's as the name suggests, it's renewable. So it's never ending in a way. The sun will keep on shining, and the wind will keep blowing. So yeah, I think that's the key advantage of renewable energy. And well, the disadvantage from a business perspective is that it's more costly a lot of times. Although, we see that in some places in the world, wind and solar is becoming more competitive than coal and gas and of course diesel. But yeah, I mean, the consensus generally is that it's a lot more expensive, especially upfront. It's a lot of investment that you need to outlay upfront. So, and I think that is the biggest hurdle to renewable energy, at least at the moment in the world. Yeah, so that's why.
Okay, thank you, Mr. Jonathan. Reiterating about the statement of Mr. Jonathan. But in the cost of renewable energy is so expensive. But in Guerrilla, Listrik Nasional in Ministry of Sources of Energy, I learned about the NPV, net present value, and payback period on PV system schematic is until 6 until 9 years about the payback period of PV system what installed. Okay, thank you, Mr. Jonathan. The answer 2 is Ms. Dr. Hawang. Please answer the question in the chat box. In Fatma, I have one question. What are the advantages and disadvantages of using renewable energy?
Okay, the advantage and disadvantage of renewable energy, right?
Yes.
Yeah, I think the drive, right, for adopting renewable energy certainly from at least from like a scientific perspective, that is certainly want to decarbonize the energy system. You don't want to have like a coal-fired or other gas and other oil-fired power plants, because the evidence show that all those fossil fuel are going to generate a lot of carbon dioxide emissions and causing like climate change. That is, I think a lot of people do believe that. So there's a strong drive to replace all those fossil fuel generations to renewable energy. And that has to be done in that sense. That is for the world, actually, right? For Earth, for human. So that has to be done, and that's the advantage to like for the sustainable kind of for development for human society, right? To support all the activities and the economy. But the disadvantage certainly, at least from the technical perspective, renewable energy in most cases are not dispatchable. Means that you cannot control when the renewable generation, right, would supply energy. For example, if there's no sunshine and you don't have solar generation, even you have the solar panel installed. If the wind doesn't blow and there's no wind, so in that case, actually, you don't have a stable supply from renewable generations. That causes a lot of challenges to run such a system, especially in the future, that to have 100% renewable energy in the in our power system, right? So it is stochastic, it is intermittent, it is pretty random, and sometimes undispatchable, and for sure. So all these are actually the kind of the drawbacks or the disadvantage for us to use renewable energy. But that's the reason a lot of research